This is Unit 2, Video 7. In this video, we'll talk about naming a second class of compounds called covalent compounds. So we've talked about ionic compounds before, and ionic compounds are made of ions, namely a cation and an anion, and usually the cation comes from a metal, and the anion comes from a nonmetal. In the case of covalent compounds, what you got is you have two or more nonmetals. So here it says nonmetals will usually, now again this is usually, there are exceptions, and the classic example is water. Water is a covalent compound. Now the reason why it's not an ionic compound is because the electrons in the water molecule are shared. Covalent compounds are made by the sharing of electrons, whereas with ionic compounds it was a transfer of electrons. So another example of it is methane. This is the natural gas that we have in the laboratory and at our homes to heat our water. And what you see is you see the carbon and the hydrogen sharing these electrons. All these electrons are actually being shared. They are actually the valence electrons, not the valence electrons are the ones that are being shared. Okay, and so we'll dig deep eventually in a future chapter to what these compounds are, the differences between their properties and so forth. Right now we're just going to name them. And here are the naming rules. For these covalent compounds, we are going to use special prefixes. The prefixes mono, di, tri, tetra. And these prefixes just simply mean how many you have. So, for example, mono is 1, di is 2, tri is 3, and we have some English words that actually use these prefixes. This is a trident. And tetra is 4. You may know about the famous game of Tetris. Each piece has 4 blocks. A very, very important game to play regularly for the improvement of concentration and mental skill development. Penta, we know about a pentagon, we know about a hexagon. The government building that houses the military control center is the pentagon. Hepta would be 7. Octa, we all know octopus has 8 legs. Nona, and finally deca. And here's a guy throwing a sphere with an angry look. Now these are going to be used for covalent compounds. And as you'll see, covalent compound naming will be very, very much simpler as compared to ionics. So rule number 1 says, for the first element, use the prefix except if it's mono, except if you're just one. So in the case of CO2, you say carbon dioxide. Notice you don't say mono, you don't say 1 for the first one, even though there's 1 there. But you do say it for the second one. And so for the second element, you put the prefix first, even if there's a mono, and then put the "ide" at the end. So again, the example would be carbon dioxide. Notice no mono for the first element, but you would if it were the second element. The third rule is a small grammatical rule, really, and it says drop the O or the A at the end of a prefix if the second element is oxygen. And this is so that you don't have a double vowel. The example is N2O5 is dinitrogen pentoxide. Even though 5 is penta, we drop the A so it doesn't sound like pentaoxide, but rather pentoxide. This almost exclusively applies to oxygen. Alright, let's try some examples. And here we have naming 4 compounds. So all you have to do is find what B is, and B is boron, and there are 2 of them, so the prefix goes in front. So you say diboron. Notice the first element doesn't really change in its ending, diboron, but the second element, having 6 hexa, and we do change the second ending to "ide," as we did before. So hexachloride. So diboron hexachloride. Alright, how about CO? Now, we don't use the prefix for the first mono, for the first one, so we just say carbon. But we do use the prefix for the second one, so we say monoxide. Carbon monoxide. It's a very interesting compound, actually a poison, and carbon monoxide poisoning is is prevented by having a carbon monoxide detector in your home at all times, so make sure you obtain one. So P5010 is the next one. 5 again is penta as a pentagon, so pentaphosphorus. Kind of a long name. Pentaphosphorus, and then 10 is deca. So we don't say decaoxide, we drop the A and we say decoxide. Pentaphosphorus decoxide. And the last one here, we have nitrogen. Again, no mono for the first element, so just nitrogen. And then H3 is trihydride. Tri and hydrogen becomes hydride. Nitrogen trihydride. Now, this compound actually has a special name. This is a famous compound that has a common name because it's so common in chemistry, and it's actually called ammonia. Ammonia. So no one really refers to it as nitrogen trihydride because its common name is known as ammonia. From the common name, you may recall we had a prefix, or not a prefix, but a polyatomic ion called ammonium. This right here with a +1 charge is ammonium, which comes from ammonia. That's the idea. Alright, not too bad. Go ahead and try a few on your own. And then let's talk about naming hydrates. Now, hydrates is a special class of compounds that have water in them. These are ionic compounds that contain H2O molecules in their structure. Again, ionic, so we'll have to use ionic rules, as you'll see. And if you heat these compounds, they'll actually remove the water. The water will be released. A good example of it is this blue colored compound. This is actually copper sulfate. And if you heat it up, it will become white. It'll lose the water. Now, the water is embedded in the molecular structure or the bonding of the molecule, so it's not like someone got it wet. Rather, it will absorb water from the air, for example, to attain this compound formula. So many ionic compounds will do this. This is actually pretty standard with ionic compounds. Some ionic compounds do it to such an extent that they actually will look like they've melted because they've taken so much water. They get saturated with water. And here are the rules. So the rules are actually quite simple. The ionic portion, you name it same as before, same as we've done before, just ionic rules. And then the water portion will actually use the prefixes. So it's like we're combining the two concepts together now. So if you have two waters, for example, you'll call this dihydrate. And hydrate is referring to water. So the original compound is barium chloride, and then you say di for two waters, and hydrate. So barium chloride dihydrate. And these are oftentimes used as desiccators. And desiccators meaning they remove water from the air. So everyone knows about these little packets of silica gel that are placed in food items or maybe shoe packages to absorb the water. This is actually silica gel. This is not really an ionic compound, but oftentimes they use ionic compounds for the same purpose. And notice if you add the water back in, it'll absorb. The compound will absorb. Alright, so let's try a few, and then we'll go on to a few more naming rules. So example 7, we have K2S.5H2O. This is named as before using ionic rules. That's potassium sulfide. Notice that the potassium, remember, does not change, but the sulfur becomes an I. And then the 5 is penta, and the water is hydrate, so pentahydrate. Potassium sulfide pentahydrate. Now, be careful, you do not need, a lot of times students will try to put a di in front of potassium. This is wrong. You do not need di because di and tri and tetra is reserved for covalent compounds. Water is a covalent compound, but potassium sulfide is not, so do not put dipotassium. Ionic compounds don't need the prefixes because we know their charges and we can construct their formula. The next one is CaSO4.2H2O. So this here has a famous polyatomic ion. This is sulfate. And again, remember, sulfate is different from sulfide. Sulfate is the polyatomic, sulfide is the monatomic. That's just sulfide. You get calcium sulfate. And as long as we know the prefix for 2, which is di, we can name dihydrate. Calcium sulfate dihydrate. All right, let's go ahead and write a formula given the name. So we have magnesium nitrate hexahydrate. So we'll have to match up the charges of magnesium and nitrate. Magnesium from the periodic table has a +2 charge. Nitrate is a polyatomic ion. This is Nick the camel, this is the Nick, NO3 with a -1 charge. And so we would need 2 nitrates for every magnesium. So we'll write magnesium parentheses. Remember, you need parentheses if you have more than one polyatomic ion. And then hexahydrate, put little dot. Put a 6 for hexa, and then H2O. Now that dot is a strange way of saying that the water is bonded to the magnesium nitrate, but not very strongly. In fact, if you heat this compound up, the water will be released, and that's the idea. And then the last one, tin 2 chloride trihydrate. Now, what we've got is we have Roman numeral. Remember, Roman numerals are used for D block elements, but if you take a look at tin, element number 50, tin is actually not a D block element, it's a P block element. However, it's the exception to the P block rule. It's actually a methyl in the P block at the bottom. So there's 2 forms of tin. There's tin 2 and there's tin 4. So in this case, we're dealing with tin 2. Tin has the symbol SN. It's a +2 charge. Chloride, we know, has a -1 charge from the periodic table. So again, we need 2 chlorides for every tin. So we'll say SnCl2, and then dot 3H2O for trihydrate. And that's tin 2 chloride trihydrate. Alright, go ahead and try a few of these on your own, and that wraps up video 7.